Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Welcome everybody, come to our What's Hot lecture. And we're so delighted to have Dr. Eric Satomi come here to talk to us about the electrical vehicle. It's very hot these days. And Eric had a PhD from University of Washington, and he got the Chairman's Award when he was at University of Washington. And then now he worked at the Alstom, and he also the chair of electrical vehicle working group at IEEE. So he's expert, I would think, for electrical vehicle. Please welcome Dr. Eric Satomi.
Thank you. And it's Sartome, by the way. It's a bad name no one can pronounce it right. So yeah, my name is Dr. Eric Sartome, and I'm going to be talking about the ABCs of EVs, because, you know, it kind of rhymes and it's a catchy title. What I'm going to be talking about today, just a brief little introduction on electric vehicles in general. Talk a little bit about the two best-selling electric vehicles as well as plug-in sales, and then I'm going to go into a long story about taking a road trip in a Tesla and use that as a vehicle to introduce the various issues that there are with electric vehicles in ownership, charging, and some of the grid stuff. So first, EVs. Look at them, they all drive in. They're awesome. Why do we want electric cars in the first place? There are three big reasons why people would want an electric vehicle. The first is the energy independence and security. Electricity is produced almost entirely with domestic energy resources. Some from Canada. We import some lovely hydro from there. But for the most part, it's all locally produced. And also, it's not dependent on any one particular fuel. So if there's a price spike in coal for some reason, it's not going to terribly affect the price of hydroelectric or natural gas, maybe natural gas a little bit. But with a diverse mix of fuels, you're not beholden on any one particular region or on any one particular industry to set the prices like you are with petroleum. The other one, which is sometimes debated, is reduced environmental impacts. At least locally, where the electric vehicle is used, there is significant reduction in emissions because the electricity doesn't make any exhaust at the point of consumption. Depending on how the electricity is produced, it could be cleaner or dirtier. However, the efficiency of large plants is still much better than smaller distributed engines. And so, yes, I posit that there is a better positive environmental impact of driving an electric vehicle, even if you are 100% coal, which no grid in the nation is 100% coal anyway, so it's a moot point. And then the third reason is the improved driving experience, which in my opinion is kind of almost the most important. There's instant torque available in an electric vehicle from a full stop, which makes it extremely responsive and gives some amazing acceleration. There's also no engine noise, which gives a much quieter drive. There's no engine vibration, which gives you a smoother drive. Those are all premium features that people will pay a lot of money for, and with an electric vehicle, that's just the base. It's standard. So what types of plug-in cars then are there? There are city-type electric vehicles, such as the Nissan Leaf, the Myvi, the Honda Fit EV, Ford Focus Electric, and a whole bunch of others from a host of automakers. There are electric vehicles that can go farther than 80 miles, and they only happen to be made by Tesla. 200-mile plus EVs, I like to call them. There's not really an official term. And then there's plug-in hybrids, which get the sort of high range and the electric vehicle part. So they can go short distance on EV mode, and then they can extend with gasoline backup generator. So they're sort of like the bridge in between these two. And technically, these are not official categories. So it's important to differentiate these two, as you will see. How does sales look for plug-in electric vehicles since 2009? And I say 2009 because it was a very important year. Our fine president made a pronouncement that by the end of 2015, this year, in thus 8 months, there would be 1 million electric vehicles on the road, or 1 million plug-ins. And we're sitting right now at approximately 312,000. So we're not going to get that goal. Sorry. Not going to happen. But we'll get probably around 400,000-ish, which is 40%. It's still very good when you consider that every year more plug-in sales than the year previous. Now the electric vehicle portion, dang it, the font has changed on this computer, is 47% are pure electric vehicles. And of the majority is just of two, the Tesla Model S and the Nissan Leaf. And interestingly, about 80% of all, over 80% of all plug-in sales are just 4 different models. Plug-in Prius, Chevy Volt, Nissan Leaf, and the Tesla. If you were to do this pie chart in terms of money spent, you would find the Tesla would be closer to around 40% because it costs like 3 times as much as the others. So you could argue that there's a big market in terms of money to be spent on electric vehicles that can travel far, or you could also argue that there's a big market for electric vehicles that are just for high-performance cars in general, irrespective of whether they're electric. So let's talk about the 2 best-selling electric vehicles, because it's sort of an interesting breakdown of the stats. The Nissan Leaf 24 kilowatt-hour battery has passive thermal management, which means they don't have any fan. I think they have fans. They don't have any sort of liquid cooling. The battery just radiates heat out into the world, and just hope the ambient temperature is cold enough to have that make a difference. And if you're in Arizona or New Mexico, you could have problems. It gets 84 miles EPA range, which if you're driving in 70-degree weather on a nice flat stretch of road, that's very attainable. If it's hotter, you do worse. If it's colder, you do much worse, because heating is more of a tax on the battery than air conditioning. It has 3.3 or 6.6 kilowatt AC charging depending on the option you get. So that just plugs in sort of any wall socket. It can get an optional quick charger for 50 kilowatt DC charging, and we'll talk more about that. And it seats 5, and there was something else, but once again, I said fonts on a different computer. Must not have been important. Oh, it was how much it cost. It cost like 32,000 bucks. The other second best selling is the Tesla Model S, which is 60 kilowatt hours or 85 kilowatt hours. And if you're a Tesla fan, you know that this is dated by like a week because they just discontinued their 60 and have replaced it with a 70 kilowatt hour all-wheel drive. But I didn't take my road trip in a 70, I took my road trip in a 60, so I'm leaving it up there because it makes more sense of what we were using. It can go 208 to 265 miles, depending on whether you got the smaller or the bigger battery. It can charge from 10 to 20 kilowatts, AC depending on your options, so much faster. It has an optional 135 kilowatt DC charger, which can really recharge you. Seats 5 plus 2. If you get the option, you can have 2 rear-facing child seats, so it's bigger, it's faster, it goes further, but it starts at $78,000, which is also raised by $5,000 now because they discontinued the cheaper one. Still a good deal. Well, if you've got that kind of money, it's a great deal. So now I'm going to talk about how life works with one of these electric cars in the context of my wonderful, awesome road trip. to a thing called TMCConnect. It was once called Teslive. There was some legal spats. It's the Tesla Motors Club. It is a web forum where a bunch of nerdy people that like electric cars, specifically Teslas, way too much, spend too many hours per day chatting about things on the web. One day they decided that they were going to have an official conference, and so we started going down because, hey, Elon Musk was going to talk, so who wouldn't want to see him? Also, they were having some cool panels, and they wanted to invite technical people, and so they invited me to give a presentation. It's not officially affiliated with Tesla Motors. It's just a bunch of fanboys going down to talk electric cars. So that is our context. I am not a person that can afford a $70,000 car, and thus it's very difficult for me to justify budgetarily taking trips down to California for a web gathering to talk about expensive cars I probably won't be able to afford anytime in the next decade. So I posted a thing on the forum saying, hey, anybody want to carpool? I will pay for all the electricity for the drive down. And that's a funny joke that you will understand a little bit later in the presentation. And some dude by the name of Paul from Vancouver, BC was like, yeah, I'm driving through there. I'll give you a ride. And thus, our trip. We had Paul's beautiful dolphin gray 60 kilowatt hour Model S to drive us down there. Our route was, well, the total route of the car was Vancouver, British Columbia, all the way down to TMCConnect in Monterey, California. And we did Bothell, my house, to Sacramento, California in a single day, 760 miles, and we left at 6 a.m. And we stopped at every Tesla Supercharger, the little T symbols, on the map on the way down there. And we'll talk a bit more about those. And we calculated our charge for each leg using a tool called EV Trip Planner. And this is a really cool thing that somebody just made out of the goodness of their heart. They said, it'll help electric vehicles travel further if you know how much energy you need to get in between any 2 points, so it helps kind of solve the range anxiety. So let's route you through chargers, and here's how much charge you would need. And you input your EV type, your average speed that you're going to be driving, be honest, because it uses more energy, no law enforcement are looking, what you want your internal temperature to be, what the weather forecast is supposed to be along your route, and it looks at your route and finds the elevation changes, and it calculates how much energy you will need for each leg. And we verified, we always gave ourselves an extra 10% buffer, and we found that we were always within the 10%. So it was a very accurate tool accounting for like mass, weather, temperature, and everything. It was a really good thing that someone put a lot of physics into just to give it away for free so we can make our road trips easier. Supercharging. A free service for all Tesla owners. So when I offered to pay for all the electricity, he joked, he's like, I want you to write a check to Tesla for all this stuff. And I was like, no, I'll pay you for the electricity you had to buy. So there's a picture of me standing in front of a supercharger. The charger itself is hidden behind the fence there. And these are the bays. They are spaced every 120 to 170 miles along the freeway. So if you've got a car that can do 200 miles, you can hit every single one of them. They have 2 to 5 chargers at each site, but there are twice as many bays. Each charger is 135 kilowatt hour. And the first car that plugs in to the to a charger gets the maximum the car can handle. And then the next car that plugs in gets whatever's left. And as one car ramps down, the other car ramps up. And so if 2 cars plugged into the same charger with the same battery state of charge, they would hit full at the exact same time. But the first guy would hit 80% probably 15 to 20 minutes before the second guy did. And so if you want to charge fast, you see everyone's spaces because the chargers are numbered 1A, 1B, so on. And so we all spaced out so we could charge quickest as possible and then go. How long? How long? I'm getting to that. I mentioned about ramping up and ramping down. And so there's a little bit of lithium-ion battery charging physics here. As you charge a cell, It starts out with a constant current over time until, as the voltage rises, it hits a certain voltage of the battery, and then the current drops off exponentially as it charges faster and faster. So with the first person that plugs in at the supercharger, they get this, and the next guy gets the dregs. And as he starts to ramp down, the other guy ramps up exponentially, and they'd finish at the same time. But, you know, you don't want to be the guy that, after 80%, you're pretty much good to hit the next supercharger. So the guy that's plugged in after has got to wait an extra 15 minutes. But, you know, it's free. Can't complain too much. Some technical aspects of supercharging. DC to DC. So it bypasses the car's onboard AC charger, and the supercharger itself talks directly to the car's battery. And it bypasses even the car's onboard battery management system, so the supercharger decides how to manage all the cells and everything in there. It is 330 volts and up to 375 amps. You see, the car actually tells you, so we were getting 332 volts, 301 amps, because we had a 60. If we'd had an 85, we'd have been getting around 385 amps. But the 60 kilowatt hour battery has fewer cells, so it can't handle the same maximum charge rate as an 85 kilowatt hour battery. It's got a really big, heavy cord, because, you know, 300 volt, 400 amp cable, a lot of insulation. It's also really short and stubby, and there was some interesting conjecture about why. And I posited to the people that it was so you couldn't loop it up and make a gigantic inductor while you were charging your car. Which now there's some people that say, maybe we could coil it and see if we could like suspend paper clips in between the, who knows? I give them bad ideas. Yeah, and it'll charge faster with an 85 than with a 60. Experience of a supercharger. So how does it work? How much time? About 15 to 40 minutes, depending on how much charge you need, which is back to that EV trip planner. So whenever we stopped, we knew exactly how much we needed to charge the car up to. So some of our stops were only 15 minutes, and we really could have even skipped that supercharger altogether, but we wanted to get the experience of charging at all of them. And some of them were 40 minutes because we needed a lot. The biggest one was when we were going over Grants Pass in Oregon all the way to Mount Shasta, because you go up really high and over. And that was, so 15 to 40 for every 1 to 2 hours of driving, depending on. So on average, about half an hour of stopping for every 2 hours of driving, which was sort of nice, relaxing. It's not terribly slow, but at the same time, it's not super fast either as far as your trip. All of the supercharger locations have restaurants and places with bathrooms, mini marts, and some of them had some really interesting places with local foods, and we found a brewery next to one of them that had its own house-made craft root beer, and that made me really excited because in my spare time I also run a blog where I write about craft root beer, and so I was like taking a picture and drinking their root beer and putting it on my blog, and like, yeah, Tesla root beer, it works together. And then you meet lots of other Tesla owners, and you can sit and chat while your car's charged. Somebody's asking a question. Do we want to save questions to the end?
80 miles an hour, 2 hours, you're 160 miles.
Yep.
Was the car a 200 or 260 range?
So ours had 200 range. So when we were going 70, 80 miles an hour, which we did. I mean, we didn't. Yeah. So our functional range was about 180 miles. So yeah, after 160, we would want to stop. For the bigger cars, they could hop in between every other supercharger. And so then you could kind of do some optimization to see, well, if I charge at a certain rate, I can put that rate as far as miles per hour that I gain into my battery, and then I can look at how more frequently I have to stop as I drive faster to try and see, is it worth it to drive faster to the next supercharger or to drive slower so I can bypass a supercharger. And for the most part, like, drive fast, supercharge, because supercharging is faster than you can legally drive. So you'll like charge at 200 miles per hour, adding mileage to your car. So, but you know, we're engineering nerds, and so as soon as we were like, oh, 2 different rates, optimize it, yes. And meeting other Tesla owners to share our stories can be fun, and it could also really be annoying because we got stopped at one where the guy just wouldn't stop talking. And we're like, okay, our car's charged. Can we go now? Yeah. Oh, yeah, great story. Anyhow, we're off. So that can be good and bad. I found it overall to be fun. But Tesla's not the only DC supercharger network. There's a CHAdeMO network. And there's me pretending like it's a Canon, because it's huge cable, as like a huge connector, and it had like a trigger on it with, you do weird stuff on road trips. But anyhow, CHAdeMO, it's supported by the Nissan Leaf and the Mitsubishi Myvi. No other car manufacturers currently support that standard. Okay, the eVTOL does. It didn't at the time because it wasn't out. It can do up to 60 kilowatt charging, and this is from it's called the West Coast Green Highway. It goes through Washington and Oregon, and they stuck these every like 50 miles along the freeway. And it just so happened that one of the superchargers across the parking lot was this, and it also has another J1772 charger in there. And there's also the J1772 combo plug, which we on the Tesla forum affectionately call the Franken plug, because it looks like some sort of Frankenstein monster of the original AC, and they just tacked on some big stuff, and it's large and bulky instead of sleek and smooth like Tesla's design, and you know, it's Tesla superior. It can do up to 100 kilowatt charging, so it's better than CHAdeMO in that respect, and it's supported by the Chevy Spark and the BMW i3. So we've got 3 rival charging networks, charging standards, and various cars that do that. However, with every car other than the Tesla, you'd have about 30 minutes of charging time for every 60 minutes of driving, which starts getting really annoying really fast if you wanted to take any long-term trips. Technically, it is possible. You could drive from Seattle to Southern Oregon in a Nissan Leaf, quick charging the whole way, but you know, you're at 50% charging to drive time, so it's not a very good ratio, whereas Tesla's more like 20 to 25% charging to driving ratio. It starts to get more manageable. But other than those Leaf, which we didn't really see any Leafs once we got past Portland, because they weren't out there on the freeway, but we did run into one other long-range EV, a fellow from this area by the name of Tom Saxon, who was also going to the same conference, but he was in a Roadster, and they don't have supercharging. So he was going hardcore. He had to charge at the J1772 AC, which at most is up to 80 amps, so 20 kilowatt charging, and it would take 3 hours of charging for every hour and a half to 2 hours of driving, because you know, he's got a cool car and he wants to show off his Roadster at the gathering along the web, so we passed him in Grants Pass, Oregon, and I was going to throw like a candy at him and try and like get it through his window, but I couldn't find the candy in time. Kind of sad. Let's talk about level 1 AC charging. So I've mentioned level 2, 240 volt, up to 80 amps, and the DC. So after 17 hours of driving and supercharging and having way too much fun, we ended at Sacramento, where my grandmother happened to live, at 11 p.m., and she was going to let us stay the night, because once again, I'm budget-minded, and I didn't want to go for a hotel, though the other guy would have been fine. But I was like, hey, we can meet my grandma, and that's how you have to be polite when you're traveling. If you don't stay in a hotel when your grandma lives in the same city, right? It's disrespectful. Anyhow, we showed up there, and we had only 17 miles of ideal range left, because I'd been driving that part, and I'd been driving a bit Spirited, because it's a fun car to drive. Big highways, late at night. There was a supercharger in Roseville, California, about 10-ish miles away, so that was cutting it a little close. So we plugged into just the regular old outlet like you see on the wall over there in my granny's garage and start plugging in overnight. She's got a really old house, and so the wire's not so good, so the voltage drop was pretty heavy. The car actually detected that the voltage drop was severe and dialed down its charging current to a Peaslee 9 amps, which would have taken us over 2 days to fully recharge. Had we done that, we charged for 12 hours and got 30 miles of range, so yeah, to get our 180 back, so 6 times 12, it would have been a long time, a couple days. But that's okay, because it gave us just enough buffer to make it to a supercharger, and it would have been fine. So we've got 3 different types of charging you can do with an EV. You've got just your wall sockets, you've got your nice connectors, and your high-power DC. Of course, we wanted to go meet up with some other members in the Sacramento area, so we were going to have a barbecue at some other rich person's house that owned like a ranch in, oh, where was it? Someplace near there. Owned a ranch, and they called it affectionately Picnic Creek. And she's like, Model S's can charge at the Supercharger, but anybody else that's got an EV, like Tom Saxon, who'd be coming in, barely make it in time, he needs to charge. And anyone else that's got a Roadster, and anyone that's got a Leaf, or anyone that's got a BMW electric or the Fiat, they can all charge at my place. And there was a lot of people that started responding on the forum that said, we want to charge. And I'm being a power engineer here, and I said, well, wait a minute. If we're going to all charge, what's going to happen to the distribution transformer if everybody starts plugging in an awful lot of load? And that got her concerned as well. And she's like, well, I only have 2 chargers, an 80 and a 40 amp that'll be running simultaneously. I said, well, that should be okay. And then just to make sure, we called PG&E and said, hey, here's what we plan to do. Will our transformer handle it, or are we going to blow up? And the engineer said it would be okay, so we said it would be his fault if we blew up the transformer. We could have probably put, she had a 50 kVA transformer, we could have thrown another 2 chargers at it, but that would have been max. So there's a lot of people, as you see from the drone photo that someone took of all of our, if even a quarter of those cars, or even 10% of those cars had wanted to try and charge simultaneously, it could have all blown up. And it begs the question, if someone not a power engineer happened to be like, if there wasn't somebody that cared at the gathering and everyone was like, we'll just charge, what could have happened to the grid?
Are they 3-phase or single-phase source?
I don't know. I think she might have been single-phase. It could be either. It was sort of a half rural residential out there. So yeah, it was big enough. The next day, we decided that we were going to go to Monterey for the conference. We supercharged our way there. And then there was another group of people say, we're going to drive along the Pacific Coast Highway for like 100 miles, and it'll be really scenic, and it'll be really fun. And it was 131 miles. And I don't know if anyone's ever gone on the Pacific Coast Highway, but it goes up and down and up and down and up and down. And we kind of did our EV trip planner, but sometimes, you had to pass those slow RVs, and Model S corners really well because it's got all its battery weight on the bottom, and so those curvy roads, we wanted to like take it high speed and go up. And suddenly we found ourselves with 18 miles of actual miles to go to our next supercharger, and our car said we only had 9 miles left. And at this point, we were going up a hill because they're like in between the coast and the interior, there's a nice little sort of gentle hills in California, if you know the geography. So we were going up that, and we realized that, oh my gosh, we've got a problem. So we had to start doing something called hypermiling. Your air resistance from drag goes up with the cube of your speed. So by slowing down, you can actually reduce a lot of the energy that you need. Going uphill, well, there's nothing that could be helped, though we did know that we had another hill on the other side, and so the car has regenerative braking, so we could gain some back. And then another thing you can do is you can draft off of big semi-trucks, because when they go over, they make this huge curly air pocket behind them, and if you can stick your little Model S right behind there, suddenly you have almost no wind resistance, and you can just drive along nice and slow like the semi until you start going downhill. And we made it with 6 miles to spare. And the interesting thing about this is we had like breakfast at an IHOP or something while we were supercharging, and then we went back, and he was like, let's give it like an extra 10 miles just to make sure. And I was like, oh, I'm sure we'll be fine. And the guy was like, no, I need to give it this extra. So we sat in the car for like an extra 10 minutes for it to get that. And it's a good thing we did. If it had been up to me, we would have probably died just right before we pulled in. So even supposedly EV experts, there's a bit of a learning curve where you may think you can do it all. You can't actually do it all. Well, you can if you're careful. And then we ran into another problem because we were south of our conference that day, and we showed up at the supercharger, and this is what we saw. There were 2 open slots, and our little caravan had 3 cars driving, so one person had to wait. Well, everybody plugged in. And then, because we were having a conference to the north, so a bunch of people from LA kept driving up that day, and more cars were showing up, and we were all queued up there. There happened to be another 80 amp charger off screen, but it brought an interesting issue of, well, what are you going to do as EVs start becoming more prevalent? Because, the half of these people were going to the same conference, so it was all friendly, and we were all good, and we're all Tesla owners. But what happens when they have multiple makes and models of cars all trying to queue up, and who gets priority? And it could be a problem in the future. Something to think about as you do infrastructure. Maybe there needs to be some sort of, in addition to free superchargers, there's like gas station type ones where you have to pay to get it, because some people might look at the long wait and just say, yeah, I'll pay $10 to charge my car right now, so I don't have to wait with that. Either way, there's going to have to be a lot of them. When we finally got to the conference, I gave my presentation. And my goal was to educate lots of EV owners about what the engineering community has been doing with the research in electric vehicles and how it relates to the grid. Because most of the Tesla owners are not electrical engineers, and those that aren't power systems engineers, so they kind of have an idea, but they don't know. So first, a little overview of the power grid for anyone that doesn't know. We've got generation, which is renewable, because our electric cars are clean, nice wind power. And we've got our transmission grid, all the big towers that everyone sees. And then we've got our substation, to our primary distribution, to our secondary distribution, to give our full distribution system. And I focus on this because we get some wonderful electric vehicle problems on our distribution system that the transmission system doesn't really have. For our generation, I taught them about how is our generation broken up. There is a daily load curve, and it's served by 3 types of plants that are called base load, intermediate load, and peak load. So our base load is big plants that are very expensive to build, that are very cheap to run, but they don't like to change their output very much. They've got a lot of inertia, so they can operate at a fixed rate very cheaply. And it's coal and nuclear for the most part, and hydroelectric up here because go dams in Washington. But everywhere else, hydro is not so much used for base load, but they don't have big rivers like we do. Intermediate load is stuff more like your smaller plants, so they're cheaper in the sense of capital cost. They have less inertia, so they're more able to change their output as the load goes up and down. They're more expensive to run, so these are sort of your natural gas, combined cycle plants. In some areas, they're actually smaller coal plants. In the Northwest, it's still hydro, because go hydro. And then for your last little bit, you've got these very cheap plants, because they don't run very often. They're cheap to build. They can turn on. They're very responsive, but they're really expensive to run. And that's things like combustion turbines, or in some cases, reciprocating engines. And so this is the really expensive, dirty power. This is the cheap power, intermediate power. And in the Northwest, it's all hydro for the most part, though Puget Sound Energy has got some natural gas as well as some of the other utilities. We're still 70% hydro. So what sort of issues do electric vehicles cause when they start charging for the bulk generation? As you saw with previous supercharger things, when you get a line of cars at 135 kilowatts a piece, you're starting to run half a megawatt to a megawatt of power. Starts becoming a very serious load. As you have that distributed all over the state, you're going to need a lot more energy, not just for the superchargers, but just cars in general. As you transfer a type of energy usage from one fuel source to the electricity, you're going to just have more energy. So you're going to burn more fuel in the plants that you've got, and sadly, if you're hydro, you only have a finite amount of water that comes down your river. You're going to have to spill a lot more of it, and that could be issues. Also, you can add a lot more load levels, higher loads, because this stuff could happen coincident with demand. So you might need to build more peaking plants, or you're just going to have to run your other peaking plants for longer. So it could be less efficient to charge your electric cars. So there's some issues with that, though it's not the main one. And then some people say, well, you know, electric cars, they can pair well with renewables, and we'll just charge them when renewables are going, and then it will solve all the problems. Well, sort of the problem with that is just when are your renewables generating? In some places, you get lots of rooftop PV that are changing your load curve. Here's what's actually happening in Hawaii on lots of distribution feeders where they're backfeeding in the middle of the day because they've got so much solar on their rooftop PV. And California, they expect California's total load to start looking like the Hawaiian load in the future. So if you wanted to sort of charge in a way that's friendly to bulk generation for your electric cars, you say, well, I guess charge them in the middle of the day. Because if you want to pair with renewables, that's what's happening. But what if you live up here in the Northwest or just any place where you've got a lot of wind? Well, here's a BPA load curve for one day in, I think, January. And here's the actual wind generation. And you notice that the difference between load and wind is really tiny at night, whereas very big in the day. So in this case, you'd want to charge your electric car at night to be friendly to the grid, which is opposite of some other places if they've got solar. And that doesn't consider our distribution grid. So what happens when we charge electric vehicles on the distribution grid? We can have line overvoltages. We can have voltage sags because we keep adding more load. On our secondary distribution, we can have transformer overloads. We can have the secondary triplex lines also overload and catch on fire because they've got rubber insulation on them. So members of our club forum had posted about different events where they had met up a bunch of EV owners. And there was wonderful stories about secondary distribution lines catching on fire and burning down, and suddenly the entire block going dark because they blew up the transformer and oops. Or they went to a mobile home park and they blew up the mobile home parks, like the RV park's transformer too. And the beauty was that these failures didn't, like some of them happened in the middle of the day, some of them happened while they were trying to charge overnight, so there wasn't really any sort of hard, fast rule of if you want to be friendly to the grid, when should you charge your car? And so the solution that's sort of being, yes, question?
Why wouldn't the house breaker break first, your main, to protect it?
Because it wasn't quite enough overload current to be seen as like a short circuit, so it was just barely enough to overheat the insulation and light on fire in that case. And with the distribution, and so that was when the secondary line caught on fire. The one with the distribution transformers blowing up is because it didn't overload their house, but all the houses were heavily loaded, and that was just the final straw.
Drove 190 amps on a 200 amp panel, the lines start burning?
Yes.
Sure.
Absolutely. Yep. Yes, definitely. If you and all of your neighbors max out your loads of your house, but keep your breaker not overloading, the transformer will blow up, unless your utility really liked to buy extra large transformers.
That's because the utility is not required to follow the NEC like we are.
It's also because the probability of that happening is extremely small, where you don't usually have all of your loads synced up, and then
And they size their wire accordingly, which they're small.
yes, because you want to be cheaper. Anyhow. So yes, how could we solve this problem? So the current research and the stuff that I've been looking at is one solution is a charge valet that would be offered by, I call an electric vehicle aggregator, somebody that collects the information from a lot of electric vehicles and can tell them when the best time to charge is. They would have global knowledge about the system conditions. They would be able to ensure that the car got charged when it needed it, and they could match the owner. They say, how do you want to charge your car? Do you want to charge it with the lowest CO2 on the grid, or do you want to charge it at the cheapest price, or do you want to charge it with the friendliest to the grid because you're a power system nerd and you just want the grid to be happy? And they can match your charging objectives for you, and they can give you periodic reports showing you your savings as far as CO2 saved or money saved or transformers saved from an untimely death. And they could also couple this stuff with more advanced vehicle-to-grid solutions. Vehicle-to-grid, what is that? That is the provision of energy and/or ancillary services from an electric vehicle to the grid. So your car would be sitting there charging. into the grid. You would know its location through GPS. Wireless provider would be able to talk to your car over the internet. Driver's usage profile and preferences would be known by this aggregator. He would sell the car's ability to change its output to the grid operator for money, and some of that money would come back to you. Why does that work? First, we need to understand something about energy markets. Here is a daily load curve. Every hour, they do something called economic dispatch of their generators and set their generators to generate in nice fixed blocks of power, and there's pricing for that. But you notice that doesn't quite fit the curve, and so they have what's called frequency regulation, which takes out that higher frequency component and smooths it out as it travels within the economic dispatch. And then you have the case where what happens if suddenly one of your generators trips offline for some reason? You need emergency reserve or responsive reserve in some markets to be able to turn on a bunch of extra generation to meet that or drop a bunch of load. And these, in places not in the Pacific Northwest where they have lots of cheap hydro, but other places, they have a market for all of these solutions, and participating in these markets can be extremely profitable, especially if your dispatch cost is negligible like it would be for an electric vehicle. So some aggregator would go into the market and bid all sorts of cool capacities using sweet algorithms like the ones that I came up with. And then how would it look for you, dear owner of your Tesla Model S? You would have your car, so this is the instrument, this is the display of the car while charging, and it says what your charge current is, your battery state of charge, and your car can be set up to automatically, so the telemetry in this case I said was Twitter, because it can be done, but you could have a more advanced telemetry, but it says Bob's Tesla is currently charging at 40 amps, battery level 75%, and then the EV aggregator says, oh, the system tells us we need to charge more. So suddenly, it sends a command, your charge rate adjusts, and then telemetry comes back, oh, he changed his charging rate. And then suddenly, they need you to do less. So it goes down to 30 amps. And then the next instance, it would go down to 23 amps, etc. And so they could make your car charge all jagged instead of smooth, which doesn't affect your car's battery or anything, but gives the grid nice smoothing, gives the aggregator nice money, gives you nice money, and you can still be doing that within your charge valet preferences, and that starts getting a beautiful electric vehicle ecosystem, and that's the cool research that I've been doing. So when that, and everyone in the Tesla thing was like, that's amazing, where can we sign up for that? And I don't know. It looks good on paper. For some reason, no one's yet made a commercial project. Someone in this area had started making a commercial product out of that, and then they sold it to GridPoint, and who knows what they did with it. But anyhow, when it was all done, we decided to go back. So at 2 p.m., we left Monterey, and we drove all night to get back so I could go to work the next day. Which actually, whereas before all-night driving can be sort of a pain, if you have to stop at a supercharger for 20 to 30 minutes, suddenly the whole, no, it's okay, I can do it, and falling asleep at the wheel is less of an issue because, oh, I got to pull over the car. And then the passenger's like, well, let me take over. So it was very easy for us to switch drivers, get naps, get more caffeine. There was no, like, the impetus to keep driving through all night and go past your limit really couldn't happen as easily in an EV. So suddenly there was a big plus from from driving an EV all night. We got home at 10 a.m. the next morning, so it was a long trip. And then we plugged into my garage, which has better wiring than my grandmother's, so we could get 12 amps, 33% more for 3 hours while we took a nap because we were tired, and that got him enough buffer so he could head off to the next supercharger up in Burlington and then head off to Vancouver. And that was our wonderful trip about EVs. And the conclusion was EVs could actually work as your only car if they came with 200-mile range and they've got some sort of quick charging solution. You don't need another car like you can do it. Oh, I need to drive down to California in a day at like a moment's notice. Done. I think road tripping in an EV is actually more relaxing than regular road tripping. Because my grandma that lives in Sacramento, as a child growing up in Eastern Washington, we made that trip all the time. And my dad was the sort of fellow that stopped for breakfast and stopped for lunch, and we were going to be Sacramento for dinner time. And as a kid, you know, I mean, it gets really boring in a car. Whereas with the Supercharger, you have to stop, and you can run around, you can stretch your legs, you can see some cool stuff, and like, I had no idea about some of the cool restaurants and things that there were along that path, even though I've driven there before like 10 times back and forth because we always skipped it. However, as we learned on our PCH drive, there's still a learning curve even for the experts in the field. We almost got stranded. And also that EV charging issues for the grid can be solved through intelligent charge management and vehicle-to-grid solutions. And that's it. Thank you. Any questions?
Yeah, how would that trip have been if you were going from Billings, Montana to Minneapolis, Minnesota in January?
Well, if the Tesla Supercharger network were there, I don't think it's quite completed along I-90. You would
10 degrees below zero, and you're stopping for a half hour to charge your car. Would that extend? The heater has to go, right?
Yeah, it would probably extend your charging time a bit. And thankfully, the superchargers just aren't off in the middle of nowhere, so you'd like get inside a building and warm up, which is what we did anyways. So yeah, cold weather can make it more difficult. Yes?
You mentioned there was no degradation to the batteries by mirroring your charge rate.
Yes. If you're discharging, there'd be degradation. But if you're just charging it like...
You can vary your charge, definitely not have any issue with warranty.
Yes, you can.
Do you think they'll ever allow you to discharge? Not.
Nissan, as a result of the earthquake tsunami, actually added an option on the Leaf called Vehicle to Home because a lot of Japanese customers were stranded without power for like a week, but they had Leafs full of charge and they thought, you know, I've got enough kilowatt hours, I could run a rice cooker for a while and eat dinner, and that was specifically their use case, run a rice cooker from your Leaf. And so they've got it as like a couple $1,000 option. So if they do allow discharging under warranty, it's going to be an expensive enough option that it will cover the fact that you're going to wear out your battery faster, most likely.
Yeah, my understanding is that the Leaf has that built into it as a technology, but it requires some sort of modification at the house level to dump into the grid. But the biggest concern is the degradation and artificial cycling with the battery.
Yeah.
Have you done any research?
I've used other people's research as far as pricing for optimization within markets of battery degradation. I haven't done that myself. So yeah, Nissan has it as an option that you can enable. You would still need to make stuff in your house where you'd make sure to disconnect from the grid so you're only powering your house, just as you would with any sort of backup generation. So you'd have to pay money for the Leaf to do it, and then you'd have to upgrade your house to be able to handle.
Explain the degradation you're talking about. Oh. When you drive the car, it exhausts the battery.
Right, true. But so car manufacturers give you a warranty in terms of time and mileage, and if you are charging and discharging your battery into the grid to make a bunch of money, then you're wearing out your battery in ways that is faster in time and not at all related to mileage. So suddenly, oh, I only drove my car 20,000 miles and the battery doesn't retain charge. Well, yeah, but you were discharging it 5 times a day to take advantage of local energy spikes. You know, we're not going to warranty that if you're going to do it. So that's sort of the issue with that.
Back to the Minnesota example in the winter. I've read that range can be reduced as much as 40%.
It can, not as much with the Tesla because of the active thermal management and the battery insulation they have, as well as if you live in a place with extreme cold weathers, you can add additional insulation and thermal management to your car with a cold weather package. So there is that, but yeah, if you get super, super cold, it will affect your range. It also affects a gas car, though not as much because most of the waste from an internal combustion car is heat, which in the cold weather, suddenly that wastefulness comes in handy. When an EV, not so much, but.
That 40%
percent is actually using your heater though. If you don't
Yeah.
use your heater,
The biggest problem is
You can
resistive
save.
heating in the cars because you're in a gas car, you've got the heat, so you can just turn on a fan and blow it into the cabin instead of having it radiate. Whereas an electric car, you have to run resistive heating elements, which are a huge power draw. They might pull 5 to 10 kilowatts, and so if you're driving, then that, if you drive for 2 hours, that's 20 kilowatt hours of energy that you've lost out of an 85 kilowatt hour battery. So there goes a
2 hours at 30 below,
yeah.
you want heat.
Well, yeah, and so, I'm just saying, that's the problem. If you come up with if you bundle up in your parka and... No way. Well, the one guy drove from, yes, for mass market, no, but for us crazy enthusiasts like the guy that drove from Seattle to Monterey, stopping for 3 hours at every charge point, yeah. Yes.
So in your research, what you came up with markets versus is basically you're just talking to the car and telling it so you can level the grid out there.
Yes.
As to when it's really high peak hours, lower the amount of charge so you can even out in the area.
Well, really, the research that I did said I don't care about the grid conditions. I care about the market conditions and pricing. And the grid operator tells me what it wants. And I tell the grid operator what sort of flexibility I have in the car based on all of the user preferences and where I expect them to go and what their battery states of charge are and how fast they could potentially charge based on their connection. And I say, here's my flexibility, and the grid operator just sends me a dispatch signal from the market things, and I
Use as much as possible, so because he makes the most energy at the peak hours.
Well, it depends on how the market dispatches. A lot of times they dispatch all of their resources equally, and then you might, there's lots of different things, and that starts getting into sort of the optimization dynamics and market stuff. But yeah, it could. There's lots of things.
How much is your round trip efficiency on the vehicle to grid? So charging the battery and then pumping it back to the grid, what's the overall efficiency?
About 80%. For all batteries. I don't know, someone that works with battery stuff more might know better. It's about a 90% charging efficiency, so assuming that your bidirectional inverter works about the same and your internal battery losses aren't terribly much, so around 80% round trip.
80, 90.
80, 90. Yeah, it depends on a lot of different variables. I always like to use 80. I liked to make, when I did my modeling, I said 80% round trip efficiency because I wanted to be inefficient. So I was making a conservative guess on the amount of money you could make by doing this.
So, are there any tow trucks out there that will bring charge out to your?
AAA actually now has in certain areas have a Chidemu, the Nissan Leaf one, where they've got like a 10 kilowatt hour battery or something connected to the Chidemu thing, so they can pull over to a Leaf and give it a quick charge blast, or they can have a J1772 connection, so they can give you enough to limp home. So in certain areas, yeah, AAA has got your back. Yes.
Battery swapping.
Well, Project Better Place was really into battery swapping, and they went bankrupt. So there's that. Tesla has said the Model S is capable of battery swapping and has built a battery swapping station at Harris Ranch and has done a few pilot battery swaps. However, that's large. We speculate that it is more because they get more California Air Resource Board renewable credits for selling a car that is capable of swapping its battery, even though if none of them do. So they built a station, swap a couple people's batteries so they earn more credits with every sale, even though 99.99% of all the Teslas in the state of California will never swap their battery. It's possible. Some of the economics get interesting with it of, like, where do they store all these batteries? What if I get a bad battery when I used to have a good battery? And as I said, Better Place tried it. It failed. Tesla may try it, and if they find that people they can make money off of this battery swapping solution, I imagine that they would go for it. But the logistics seem difficult if all the cars are owned by different people. If you have a fleet of cars, say 200 cars, and you own them all, and you own the batteries, battery swapping is a wonderful solution because whenever they pull up into their bay, you swap out the batteries and you go. And so battery swapping can work. Yes.
So I see a lot of fires on the Teslas.
No. There was not a lot of fires. There were 3 fires. 2 people ran over trailer hitches, which speared into the battery. And if you take your laptop battery and you drive a screwdriver through it, it'll probably catch on fire and explode. So there was that. And then there was also some guy in Mexico that was driving like 100 miles an hour, flipped his car, crashed through a brick wall, and the car lit on fire. And he walked away from it rather unscathed for being an idiot and wrecking his car in Mexico. So there was that fire. So 1 was an idiot and 2 were big old trailer hitches that got hit and then driven, impaled by the car. So then Tesla added a big bunch of titanium sheeting, armor plating underneath it to make sure that would never happen again. And so then they released some wonderful videos of them like driving over 3-ball trailer hitches and like the hitch getting destroyed and like driving over a cinder block with the new battery armor and the cinder block getting destroyed. So yeah, there were some fires and it generated some bad press. So they they put some ballistic armor on it.
Something tells me tequila had something to do with that last one.
Yeah, the California, the one in Mexico, yeah. That's not fair to say about like car safety. Anytime someone rams a car through a brick wall at 80 plus miles per hour, you can expect bad things to happen to the car. Yes.
Is Tesla planning to continue the build out of like the free supercharge stations, and do they think that's sustainable?
Well, so supercharging, if you buy their most expensive car, it would come standard. If you bought the cheaper 60 kilowatt hour one, they made you pay $2,000 for the software unlock of the supercharging hardware, which really meant that you're paying $2,000 for the ability to charge. So I doubt you'll be using more than $2,000 worth of energy in that. So it's really, the price of supercharging is built in with the car. It's a pay up front instead of pay as you go. And also Tesla justifies supercharging out of their marketing budget because it's, instead of running advertisements, they have supercharging because people can go. And most people don't actually use supercharging that often. So, but yeah, it's an interesting question as you start getting more and more people, could something like that be sustainable? And my personal opinion is that just because you're going to get its saturation of not enough superchargers for free, that you're going to see people build a supercharging station that's a pay per charge, like $10, $20 to charge your Tesla, and they're going to build them probably close, either completely away from where existing superchargers are, so like to bridge a gap, or they'll build them close to a heavily used supercharger, so you get there and it's already completely full and 2 other Teslas just pulled in the lot, and then you see across the street, $40, charge your car now. And if you can afford a $100,000 car, do you really want to wait a half an hour just to charge so you can get on your way? So, though currently Tesla hasn't licensed it to be pay because they want to say free supercharging, but I think it's going to happen eventually. They're not going to give away free charging forever.
It seems like if one of the supercharging stations went offline, it'd be a major problem. Has that happened yet?
It has happened. I don't think the entire charging station has happened a few times. I don't know the specifics. A lot of times because there's multiple chargers at each one, so there have been times when entire chargers have gone offline, and they actually have a little number that you can call if the supercharger's not working. And sometimes there's a problem with your car, and they can actually talk to your car remotely. And there's been some time where like someone needed a firmware upgrade to use the supercharger, and so they got it hashed out in like 15 minutes, and the person was on his way charging again after this. So they're very much trying to diagnose and get all the problems. But yeah, right now the entire network is only Tesla, and if like the distribution transformer for the supercharger blew up, then everyone's stranded without and out of luck. So I would like to see in the future pay charging solutions alongside free charging solutions, premium membership.
What's a hybrid Toyota Prius? Do you say a few words about
Yeah, I talked about that at the beginning, that they've sold a lot of those. With the plug-in Prius, if you don't have a place to plug in, you just go and buy gas, which is what it is with all the plug-in hybrids.
So it's more flexible.
I personally say no, because I'm one of those purists where I like an EV to be an all EV, and I like a gas car to be an all gas car. And
advantage you talk about in the beginning, like free, energy,
they
or more or less.
Yeah, I mean, if the plug-in hybrid is essentially an EV that can't go as far or in some cases as fast as like its maximum top speed when it's all EV mode, and it's like two cars mushed into one. Instead of having a Nissan Leaf and your A6, you've got a Chevy Volt or something. So you can do both. Some people say it's the best of both worlds. I like to say it's the worst of both worlds, but it gets dogmatic. But yes, they're very practical, and they have a lot of advantages of plug-ins.
As high as pure EV is being
Battery. The biggest expense with electric cars is battery. So if you make a smaller battery.
In the future, because you still have your gas engine to be repaired like normal gas engines.
Okay, that's why.
There's pros and cons.
Yeah.
It is easier to transition from a regular internal combustion car to a plug-in hybrid car, because if you forget to charge it, you can always just fill it up with gas. Yes.
Just add to that, the nice thing about a PHEV is that most people drive like 30 miles in a day.
Yeah.
Most of the PHEVs that are usable have like a 30 to 40 mile range in electric. So you could very well drive around the city as an electric car and never touch the gas.
Yeah.
And then when you wanted to go on a road trip, like a Tesla road trip or whatever, you could just fire up the gas engine, it would instantly engage and you keep driving.
Yeah.
Yeah, much better.
No, it's terrible. We need to all go EV, because then you don't get to supercharge, and you don't get to drink root beer. You don't get to drink root beer at the supercharger. Yes, you
talked about all the fun things you did while the car was charging, but doesn't somebody have to stay with the car to move it as soon as it charges?
No, it's fine, because as long as there was extra bays, as long as in the time where we were overloaded, then you can look at your smartphone app. And your smartphone, everyone's got the Tesla app for their smartphone, and it can tell you exactly the state of charge, and so you would know when it's going to be done. And you can estimate how long it will take based on what you're at when you plug it in. So,
Last one.
One more question. Jason, you can ask it.
Second life batteries. How can those be used for the grid?
You set that one up, didn't you? So there's a lot of talk about after the EV batteries are technically dead for a car, they would still be able to retain like 60% of their capacity, that then they could be bundled into some stationary energy storage product and then cycled until they're completely all dead. And that could be a much cheaper solution. And potentially, if you had some sort of modular architecture for batteries that were chemical and chemistry agnostic and vendor agnostic, you could really integrate things like second life batteries into the grid. Don't know who would be doing something like that. No, that was the last question. Sorry, we have to.
We're over.
Yep.
We have an EXCOM meeting coming up, so if you'd like to join us, please come. Thank you very much.